Hello students, today I will explain the scatter plot, regression and correlation, the difference between a function and a curve fitting. So let us start with an example. So look at this, the first table, this table is given as some sample has taken. So sample 1, sample 2 and sample 10. There is 10 items are present in a sample. The serial numbers is represented by the sample numbers, and two attributes or two variables are given here. Look at this is x and this y. So the first x variable, it represents the consumption of sugar, and the y variable, it represents the gain in weight. Okay, so if I say that is consumption of sugar is 10, maybe 10 kilograms or in a year, or 10 kilograms in a month, or whatever, then the gain of weight is 5 kilograms. Similarly, 15 kilograms of sugar consumption, the y value, that is gain in weight, is 7, and so on. Okay, so there are 10 items are there, or 10 data are there, and each and every data, it represents the consumption of sugar and the corresponding gain in weight. So we say these data as a bivariate data. So each and every data is represented by two variables. That is, if I say x, these x values are 10, 15, 25. That is, x takes these values 10, 15, 25 like this, and y takes the values 5, 7 and so on, 15, 25 like this. Okay, so now we will draw a scatter plot. Okay, so according to these values. So how to draw the scatter plot in Excel? So just we select this set of data, two set of data. Now go to insert, and you will see there is a chart. This is too many charts are there. So recommended charts, there is recommended charts also, but we will select the scatter chart here. So this is bar chart. Okay, so this is line chart, and too many charts are there, pie charts. This last axis, this is called scatter. There are too many scatter plots exist here, so we will select the first one. Now look at this. This plot is called a scatter plot. Now why this is a scatter plot? In case of scatter plot, each and every point, look at this, there are 1, 2, 3, 4, 10 points are there, and each and every point represent the value of this x and y. That is the first point. The x coordinate of the first point is 10 and the y coordinate is 5. That is, this first point has 10, 5 coordinates. So we are actually representing the y-axis of this chart as x-axis as this chart as consumption of sugar, and the y-axis of this chart as gain in weight. And each and every point in this scatter plot has the coordinate as xy. That is whatever we represent the coordinate in a two-dimensional coordinate system. Each and every point can be represented by within a bracket xy in a bracket. So just like this, the value of x and the value of y, this is the x coordinate of the point, and this is the y coordinate of the point. The first point has 10, 5 coordinate. Similarly, the second point, if we select the second point, the second point has 15, 7. That is, 15 is the x coordinate and 7 is the y coordinate of the second point. Similarly, look at this, 25, 15. The series one, that is point at 25, 25, 15. Look at this, third point is 25, 15. Similarly, if we see fourth point, 30, 25. So look at this, fourth point is 30, 25 and so on. So this graph is called a scatter plot. Okay, so now look at this. This graph has a trend in an increasing manner. That is, it is an increasing graph, increasing scatter plot. Okay, now come to the second example. This is similarly the 10 data has been collected, and we are plotting the time in physical activity. There is time spent in physical activity is represented by x-axis, and gain in weight is represented by y-axis. Okay, so just like the first table, this consumption of sugar is represented by x-axis. Here time in physical activity, there is time spent in physical activity is represented by x, and the corresponding gain in weight is represented by y. Now look at this, the first sample, it is 1065, that is the 10 hours of exercise, the gain in weight is 65. Similarly 15 hours of exercise gives us a 54 gain in weight, and 25 hours of exercise, this may be in a month, in a year, or whatever, in a week. Okay, so 25 hours of exercise will give us 50 kilograms of gain in weight. Okay, and like this, now we are plotting this data. Similarly, we are choosing the scatter plot, go to insert and the first scatter diagram. Now look at this data. It has a trend, a decreasing trend. Okay, that is the x-axis is represented by the time spent in physical activities, and the y-axis is represented by the gain in weight. So we see that the time spent in physical activities, if time increases, if we give more effort in physical activity, then the increase in weight will decrease, that is the weight will be decreased. So it has a decreasing manner. But the first one, it has an increasing manner. So two scatter, we see that two different types of scatter plot. One is increasing scatter plot and second one is decreasing scatter plot. Look at the third table. This is the same table has been selected, the time spent in physical activities and gain in weight, but in this sample we are seeing some different data. We are noticing some different data. Let's plot this table in a scatter plot. Look at this. This scatter plot is neither increasing nor decreasing. Okay, so we will see this no manner, not an increasing manner, not a decreasing manner. So we will see that if we increase the time of physical activity in these samples, there is in this set of sample, we see that time spent in physical activity are increasing. There is 10, 20, 15, 25, 30, but the gain in weight is, if 10 hours of physical activities are there, then the gain in weight is 30. 15 hours 32, 25 hours again 31, 30 hours 28, 40 hours 30. So there is no relation in between these two activities. There is neither increasing nor decreasing. Okay, so now I will explain what is the correlation coefficient, how you can relate the correlation coefficient according to this scatter plot. If the curve is increasing curve, so some bivariate data is given, consumption of sugar and gain in weight, two different variables are given, and we are plotting, we are denoting the x-axis as this x, that is a first variable x, that is consumption of sugar, and the second variable y is denoted by the y-axis, and we are plotting these two plots in this two-dimensional plane. Okay, and if the curve, if the trend of this scatter plot is increasing, we will say that the correlation coefficient is positive. Okay, if we see a decreasing manner of the curve, that is after plotting all these data points into this plot, into this graphical plane, and we see a decreasing manner of the scatter plot, we will see the correlation coefficient is negative. Okay, that is positively correlated, or we can also say if it is increasing, it is positively correlated. If it is decreasing, it is negatively correlated, or the correlation coefficient is negative. But in this case, if we see there is no increasing or no decreasing manner of this curve, only whatever the physical time in physical activities, whatever the effort we are doing with our body, whatever the effort we are spending the time in physical activities, or whatever we are doing, but the gain in weight, there is no significant changes in gain in weight. So we will see the all over variation is neither increasing or not decreasing. So there is no variability, that is not now not increasing or not decreasing, then we will say that the correlation coefficient in the third case, it is almost zero. So it is we in this manner we cannot say that is a completely zero, but it is almost zero. So if the correlation coefficient is zero, then we will say there is no relation between these two variables, that is x data and y data. If the correlation coefficient is increasing, that is a correlation coefficient is positive, that is a graph is increasing graph, the scatter plot is increasing plot, then we will say that it is positively correlated and correlation coefficient is positive. If we see it is a decreasing graph, decreasing scatter plot, we will say the correlation coefficient is negative. And if the curve or the scatter plot is almost parallel to the x-axis, then we will say that the correlation coefficient is zero. There is no relation, no there is two data set are totally uncorrelated. There is not interrelationship exists in between these two data sets.